So welcome to the WEM Seminar Series number 9. It's really amazing to see that we have done it for the 9th time consecutively. And then of course, there are sometimes like internet issues, but I'm very glad that the participation of the students and also the alumni and then also the prospective students. I can see that there are some prospective students are also joining us today. So I would like to say thank you and welcome to WEM Seminar Series number 9. So to the new students, just a brief introduction that this is a bi-weekly event that we at WEM are organizing once in 2 weeks. The idea is to give an academic interactions of research of the students, and once in a while we will also have invited lecturers to share knowledge outside of AIT. So do look for that. Let me take the permission to briefly introduce the presenters of today's presentation. So please be reminded that this WEM Seminar Series will be broadcasted live on Facebook as the other previous WEM Seminar Series. So let me start with sharing the screen. Okay, so for today's first presenter, I would like to introduce Ms. Pradith Grace Buktan. So she already graduated from our program last May. So Grace is from the Philippines, and her research interests include climate change, land use change, hydrological modeling, and groundwater modeling. Coming to today's seminar, Grace will be talking about assessment of the impacts of climate change and land use change on the groundwater recharge in Siem Reap, Cambodia. And our next presenter, stop share. For our second presenter is another graduate from WEM, Mr. Sonu Kumar from India. So Mr. Sonu is going to share with us his research on evaluation of global precipitation products for hydrometeorological applications. Mr. Sono's research interests include spatial temporal data analysis, hydrology, hydrological modeling, plus trial assessment, climate change impact assessment. So with that, I will stop share now, and please, I invite our first presenter today, Ms. Grace, to start sharing your screen and start today's seminar. Thank you.
Thank you, Dr. Law. I will start sharing my screen. So can you see my screen?
Yes, we can see your screen now. You can use the, you can right click and then change. Yeah, thank you. Thank you, Grace.
Okay, thank you, sir. Good morning, everyone. I am Pradith Grace Buktan from the Philippines, and I will be presenting the assessment of the impacts of climate change and land use change on the groundwater recharge in Siem Reap in Cambodia. This is a part of my master's thesis, where my committee members were Professor Sangam Shrestha, Dr. Mohana Sundaram Shanmugam, and Dr. Salvatore Verdes. So I will be giving a quick introduction for my study, then the methodologies I used, the results and the discussion, to finally end with the conclusion and recommendations. So groundwater is very much important to us. It is the most extracted raw material on Earth, where 70% of it is in the agricultural sector, followed by the domestic and the manufacturing sector. In a recent study in Southeast Asia and the Pacific, 66% of urban and 60% of rural households rely on groundwater for drinking. However, in this Anthropocene era, natural and enhanced climate change, land use change, and human water use are creating impacts and feedbacks to our hydrologic systems, which can result into depleting groundwater and water deterioration, among others. So for the case of my study area in Siem Reap in Cambodia, it is a city of very high economic potential driven by its international tourism, as it is home to the UNESCO World Heritage Site, the Angkor Archaeological Park. In the first half of 2019 alone, over 3 million tourists visited the park. However, it stands vulnerable to climate change, and it is actually facing annual water supply deficit of up to 300 million cubic meters, posing our water supply authority and private users to tap into the groundwater resources. Although there is no serious land subsidence yet, the importance of keeping the groundwater level is very much high in this area, as it is connected to the stability of the monuments and temples. Given this cultural and economic importance of groundwater in Siem Reap, Cambodia, it is important to develop sustainable management practices. So the Siem Reap city is within the Stung Siem Reap, or the Siem Reap sub-basin, which has the Colin Mountains upstream and drains into the Tonle Sap Lake downstream. It has a mean annual rainfall of about 1,300 millimeters. Stung Siem Reap is well within the Siem Reap province, and it is also within the larger Tonle Sap Lake basin, which has the Tonle Sap Lake in its center, meeting the very large Mekong River here and draining to the Mekong Delta. It is underlain by the Cambodian Mekong River Delta Aquifer, which is a transboundary aquifer shared between Cambodia and Vietnam. So for my study, this study aims to assess the impacts of climate change and land use change on the groundwater recharge in Siem Reap, Cambodia. To achieve this, I will be analyzing and projecting climate change and land use change under multiple scenarios and assess the impacts of this to the groundwater recharge in Siem Reap, Cambodia. For the methodologies, I will first introduce the scenarios from the phase 6 of the coupled model intercomparison project, or the CMIP-6 scenarios, wherein there are 5 global path alternative narratives in the future of global societal development, SSP1 to SSP5, coupled with the enhanced forcings from the RCPs of CMIP5, or the representative concentration pathways, and we have a total of 8 alternative scenarios. From this, I have chosen SSP2 4.5 as the mid-emission scenario. This is like this here in the temperature change scale, and SSP 585 as the high emission scenario, which is a bit higher than its RCP 8.5 counterpart in terms of temperature change. So I will be using these 2 scenarios consistently in the study. For the climate change projection, I first obtained precipitation and temperature data from these GCMs, where I downloaded from the World Climate Research Program data portal, as well as I have the observed data from the Siem Reap station I obtained from the Ministry of Water Resources and Management and Meteorology in Cambodia. So I will be comparing the GCM data to the observed data using the entropy method and a weighted average technique to get the best 3 GCMs. These 3 GCMs I will be bias correcting to project the future using the linear scaling method, and to project the climate to the near, mid, and far future. For land use change projection, I have collected these data sets, and my main land use maps are from the European Space Agency Climate Change Initiative, or the ESA-CCI maps, which are available annually from 1992 to 2019 with a raster size of 300 meters by 300 meters. So I input these data sets into the DynaCLUE, the land use change model I used for this study, for it to simulate the land use map. I will then be comparing it to the observed SSECI map using the kappa statistic, where a value of 1 means a good simulation of land use map, and then further validated using the 2016 to 2019 data set. I also projected land use demand based on the narratives of SSP2 and SSP5. So under SSP2, there is agricultural expansion and urbanization and deforestation. For SSP5, however, the agricultural expansion and urbanization is rather faster due to the development, and deforestation is also continued. So with this land use demand, I assumed, and the validated Dynaku model, I am able to generate the land use maps into the near, mid, and far future. So all these data sets are also inputted into the SWOT model, or the hydrologic model, together with the observed stream flow at the Prasat-Keyo station, which is along the Siem Reap River. I will be using the statistical tools by Mariase et al. At 2007 for the calibration and validation, from where I will get the groundwater recharge for analysis and recommendations. So for the results, from my GCM evaluation, I was able to determine EC-Earth3 as the first in rank for capturing precipitation and maximum temperature in our study area, while CAN-ESM5 ranked first for minimum temperature. So summarizing these rankings, the best 3 GCMs with the least total are CAN-ESM5, EC-Earth3, and MIROC6. So these 3 I bias corrected using linear scaling method. We can see on the top row the raw data from these GCMs compared to the observed data. So after bias correction, the peaks have visibly been reduced. And we can see in the statistics here that the deviation and the error were minimized and the R-squared increased after the bias correction. So projected annual rainfall at Siem Reap shows that there is no clear disparity between SSP2, shown in blue, and SSP5, shown in red, in the future. However, for temperature, we can see that for maximum and minimum temperature, the increase in the SSP 585 scenario is rather visibly larger than SSP 245. So these are the average rates of increase I have determined, and these are comparable to another study in the same area where they got almost the same rate for RCP 4.5. However, the one I have obtained for SSP 585 is a bit higher than their RCP 8.5. So looking at this data monthly, on monthly averages, we can see that precipitation increased, but the increase is larger for SSP 5, and the peak moved from September to October in the future. Also, we can see that for maximum and minimum temperature, near, mid, and far future, temperature really gradually rise with larger increases for SSP 585. For land use change, this is the observed 2015 land use map, and this is the one I simulated in Dynaku. So calculating the kappa coefficient, I got a K of 0.73, which is already satisfactory. And using the data from 2004 to 2019 for trend analysis, we can see that there is deforestation, negative change here, as well as for shrubland. We can also see that for settlement or the urban area, the change from 2004 to 2019 is more than fourfold, meaning that it is really an urbanizing city. So I use this rate decrease and increase for the projection of the land use demand in the future. So squares show the SSP2 projection and circles show the SSP5. For agriculture, we can see that the rate for SSP2 is lower than SSP5, and the deforestation rate is same for both scenarios. While for the urban area here, the SSP2 projected land use demand is lower than that of the SSP5 in accordance with the narratives of the scenario. So in putting this to the Dynaclu model, I was able to generate these land use maps for the near, mid, and far future for SSP2 and SSP5. We can see that there is more urban area and less forest area for SSP5. So in putting this to the hydrologic model for the SWOT, so I was able to generate 10 subcatchments in Stung-Siem Reap and 201 HRUs or hydrologic response units. Then I manually calibrated and validated this until I got these results and then I got this baseline condition recharge, which ranges from 0 to 123 mm per month. So we can see that this pattern closely resembles that of the soil map, with high recharge along the Tonle Sap Lake area and low recharge for the urban area. So our result is comparable with what JICA has obtained back in 2011 for Siem Reap City. So validating our results. Also annually, the average groundwater recharge is 303 mm per year. Comparing this with the global mean and the lower Mekong Basin median, we can say that the result is within this range. So from this baseline groundwater recharge, I compared the future recharge simulated through SWOT. So this block here shows that of SSP2 for all 3 GCMs, and this shows the groundwater recharge maps for SSP5. So increases are shown in blue while decreases are shown in red. We can see that the decreases are in the mountainous areas where deforestation was projected to occur, and that also near the wetlands where there is reduction of those area in this part of the sub-basin. Also, we can see that in the urbanized area where urbanization was growing, recharge is less or rather decreasing compared to its surrounding area, highlighting the importance of land use. Also, I have projected here all of the results into one to see the temporal change. So we can see that temperature for maximum and minimum temperature are increasing towards the far future with larger increase for SSP5, as well as precipitation increasing into the far future. And our groundwater recharge is also increasing into the far future. So this is like the summary graph. I have also done analysis using constant land use map of 2010. So like there is climate change, but I kept the land use constant at 2010 level. And we can see that there is actually higher recharge compared to when there is land use change. So this means that groundwater recharge is higher when there is less urban area and more forest area. So further highlighting that land use planning will be helpful towards groundwater sustainable development. So for the conclusion, it was determined that CAN-ESM5 and CERF3, MIROC 6 are the best GCMs for our study area, and that future temperature will increase by these rates. Also, deforestation, fast urbanization, and expanding agricultural areas have been observed for the Siem Reap province, and that the urban area increased by 373% from 2004 to 2019. Effects of climate and land use changes show a general increase in groundwater recharge, except over areas where there is urbanization or deforestation. So based on the baseline groundwater recharges are the rates of, and the groundwater recharge is even higher when land use is held constant to where there are more forests and less urban areas. So for the recommendations, it is highly suggested that more data be used for more robust models. Also, other bias correction methods may be explored. The contribution of leakages from urban setting, which is also unique to urban areas, have not been included in this study, but their presence could be significant, especially when looking into groundwater quality. So they can be considered in the future. Also, as shown in the land use analysis, most of the area is classified as agricultural. Thus, the dependence and impacts of agricultural systems on the groundwater must also be considered. Careful land use planning and strategies would be helpful in the sustainable management and development of groundwater resources in 𝐾𝐲𝐝𝐿. That is all. Thank you.
Thank you, Grace, for a very exciting and interesting presentations. So with that, I would like to open the platform for Q&A. So for the audience, please, everyone, if you have questions, please unmute yourself and ask question directly to Ms. Grace. Thank you.
Thank you, Grace, for the nice presentation. Actually, what I need to know is what is the 𝐷ynaCLUE model? I have heard through research papers, but can you tell about something like how you use this 𝐷ynaCLUE model? Is it a coding to you have to develop a code, or is it a model like SWOT? Can you tell me?
It is more like SWOT. It has already been developed. So you just need to input the spatial data sets, and then together with the land use demand that you projected, then it will generate the land use maps based on the drivers that you have inputted into the system. Drivers could be like the road network, the soil type, the population density. So these are all input into that model, and then it will generate the land use map.
And is it freely available? That's a problem for the developing region, no? These softwares and this. Is it free? Is it free for everyone? The 𝐷ynaCLUE?
Yes, sir. Although it has limitations compared to the paid one, but the premium one is like for really large systems, no. But for my study, the free one is okay.
Okay. And it's very interesting to see that you have used the shared economic pathways. We have done with RCPs, and so it's a very novel thing. So it's very good, right?
Yes, sir. We should keep up with the
SSP. So community. I also don't have experience. I have used this RCP, so we also plan. So I think this study will give us good insights for us also. So thank you very much, Grace. That's a wonderful presentation with your Professor Sangham and Professor Mohan Sundaram. Thank you very much, right? Okay.
Thank you.
Okay, any more questions from the audience? Thank you, Yuru. I think your question is also what I'd like to ask about this fascinating land use change modeling.
Yes, sir. Yes.
Okay, any more questions from the audience?
Hi, Grace. Hi, Grace. I'm Kim. Thank you for that comprehensive presentation. I just have a question regarding the methodology that regarding the methodology that you used. I noticed that you didn't use a downscaling technique. Do you recommend a downscaling technique for future researches, like this type of analysis?
For downscaling, I think it can be done through statistical, which I used here using the linear scaling method, or you can also use the RCPs, which are dynamically downscaled. But when I did my study, there was still no RCM for my study area, so I used linear scaling method to downscale the data.
Can I ask what is the area of your study area?
The physical area.
Yeah, the area.
It is 3,500 square kilometers.
Okay. Okay, thank you.
Hello, Grace.
Okay. Yes, please, Suwas. Thank you.
It's me, Suwas. I'd like to ask a question regarding how significant is the result of land use change impact. So you have shown us the result, how land use change has impacted, and I find it quite interesting. In fact, your whole presentation looks very nice to me. But I want to know how significant is it in terms of any other research done before, or if you have done any kind of significance analysis, like statistical analysis or so on. So any idea regarding it?
I haven't done the analysis, I think, but we can see, I didn't further analyze this difference, but we can see that maybe we can look at the spatial distribution of this difference, and maybe we can develop like,
I mean, it can. There is there any other literatures like who has classified like this is very significant, and this is not quite significant, or something like that, and how is your result? Yeah, I can see the value.
yes. I haven't read papers
just to compare
on
the
that.
results.
Yeah, I haven't read paper significance of this type of analysis yet. So maybe I can look into that later.
Okay. I find it quite interesting because you had done two different analyses, like with climate change and just keeping the land change constant and see the results. So this is quite interesting for me, and I think it is a novel research, which I have found rarely. So if you do some kind of look forward to some kind of research done before, then it is a publicable kind. So I wish you good luck for future. Thank you so much.
Thank you so much. Thank you.
Thank you, Suwas. Actually, we have another question, or recommendation from one of the audience, but his microphone is not working. So I would like to take his permission to read the recommendation to Grace before we move on. So this is from Dr. Ton, one of our research fellow. So he recommended that you can use the recharge projection as a safe view of aquifers to recommend for decision makers. So this is like go to increase the policy implications of your research findings, and with that you can apply the pumping as safe view, and you can analyze the groundwater situation under safe view proposal. So actually this is a very valid recommendation for Dr. Ton. Thank you, Dr. Ton, for this one. So with that, I would like to say thank you, and all of the participants who have contributed very useful and meaningful questions to Grace. Before we move on to our next presenter, may I ask Grace to unshare? Yes, thank you. So before we move on to the next presenter, I have two small announcements to make. Is that for those who have joined later, Mr. Roel has requested all of the audience to put in your names, affiliations for students. Please put in your student numbers as well. So Mr. Roel, may I request you to recopy the instructions on the chat box for everyone, because we have someone who joined after the section. So please follow the instructions in the chat box to key in your name, affiliations, and for students also the student numbers. And before we move on, may I request that we all turn on our videos and give a very big smile so that our photographer over here, Mr. Roel, can take a group photo for everyone. Please, Mr. Roel. Maybe you can instruct us on your mark so that everyone can turn on.
Okay, so please open your camera and smile. Okay, for the second slot, smile. Okay, thank you. Thank you very much.
Thank you, Mr. Rao, for being a very reliable photographer as always. We're really looking forward for your real photographer soon when the COVID situation gets better. So with that, I would like to invite Mr. Sonu Kumar, so you can start to share your screen and start your presentation. Thank you.
Hello, sir. Can you hear me now?
Yes.
Yes. First of all, good morning, everyone. Today I am here to discuss related to my master thesis, which is on the evaluation of global precipitation product for the hydrometeorological application. My discussion consists of the research background, scope and objectives, and also the studies area and data and methodology, and result and discussion. Finally, we'll be discussing the conclusion part of my discussion. As you all know that the precipitation is one of the key factor in hydrometeorological and natural disaster studies. With these studies are drastically affected by the accuracy of the precipitation product. There is a lot of sources for the precipitation data set, but most of the research have pointed out that rainfall stations are the one of the major source for the accurate rainfall data. And but in the mountain region or Himalaya region, sparsity and irregular distribution of the rainfall data and rainfall station, as well as the damage of rainfall station due to the natural disaster studies, greatly affect the accuracy of the rainfall data set. So there is a lot of study is going on to find some alternative data set in data sparse region, and global precipitation product is one of the alternative to the gauge data set in the data sparse region. But the most of the study they have found the performance of global precipitation data set vary from basin to basin. So you can say it the applicability of global precipitation data set in the Himalaya region or any region, it is still uncertain, and it is always recommended to evaluate the all precipitation product before using it. And moreover, most of the research have not able to conclude that which precipitation product is the best suitable for the various application. So that's make the very challenging for our researcher as well as the decision maker to choose the best suitable product for their application. So this study will help our researcher as well as decision maker to find the best suitable precipitation product. So this study made the overall objective of this study was to access and identify the suitability of global precipitation product for the hydrometeorological application in the Narayani River Basin, Nepal. And we have evaluated the total 12 global precipitation product, including the 8 satellite-based precipitation product and 4 reanalyzed-based precipitation product. And we have evaluated based on 6 performance indicators. And after evaluating the all indicators, we have also used the ranking technique. Ranking technique was based on the multi-criteria decision making technique. Finally, after that, we have also evaluated the global precipitation product ability to simulate the discharge. So we have used the JRG4 model. It's a very popular model in the data sparse region because it required a very less number of inputs. It's a one type of lump model. My study area, as I discussed, we have taken the Narayani River Basin. Narayani River Basin is the one of the major source of the water for irrigation and hydropower generation in Nepal, and which is located in the central part of the central part of the Nepal, and originated from the China and goes to the India's in the Ganga River Basin. So we have also divided into the 6 sub basin, which is the major sub basin: Kali, Gandaki, Marsandi, Medisati, and Narayani, Budi, Gandaki, and Tirsoli. And you can see the most of the number of stations which lies in the lower part of the river basin, but there's a few number of stations are located on the upper part of the basin. And we can see the yellow color, which is the discharge simulating point. So here we have observed data, observed discharge data. So we evaluated the all global precipitation product based on ability to simulate the discharge at 2 locations. And the total catchment area of this river basin is about 46,000 square kilometer. And you can also see that there is a huge variation in elevation which ranges from the 40 meter to the approximately 8,000 meter from mean sea level. And the most of the study which was conducted in this Narani River basin have concluded that the approximately 78% of the rainfall happened during the monsoon season in this river basin. Yeah, these are the list of the all data sets which was used in this research. So firstly, it's a DM data, which was used to delineate the watershed area. And now we have a two runoff data, which was used to evaluate the global precipitation product, ability to simulate the discharge. And we have also the 36 rainfall station was collected from the DHM Nepal. Now we have a total 8 precipitation product, satellite bed precipitation product, and 4 reanalyzed precipitation product, which have a different resolution, spatial resolution. So in this study, we have taken the variety of the spatial resolution. Like we try to make the try to select the finer resolution precipitation product for the better accuracy. So these are the overall methodology of this work. So firstly, we have downloaded the all global precipitation product, and we extracted the data for the sub basin as well as each station. And then we have a hydrometeorological data was collected from the DHM Nepal. And then we also do the data quality and testing, because you know that all data are not okay. We have to fail and you have to clean the data. So we have also now we also know that the gauge data is a point data set, so we need to make it the aerial data. So I have used the Hessian polygon method to make it the aerial data set. Now, after doing this all analysis, we have calculated the 6 performance indicators, that is a POD, false alarm ratio, accuracy, and RMSE, and correlation coefficient, and percentage bias. And after calculating this all indicators, we have analyzed this all performance indicators at the different elevation, and we have also seen what the effect of the topography on their performance indicator. Now the next technique is the ranking of all global precipitation products. So we have, because these all indicators have a different direction and different scale, so we need to make it the same scale. So we have used the normalization technique to make it the same scale and same direction. And then after that, we have used the entropy method to assign the different weight of the all performance indicators. And then finally, we have used the compromise programming, which is a very popular multi-criteria decision making technique to rank the all precipitation products. So after doing this all, and we have selected the 4 base precipitation product for the evaluation against the ability to simulate the discharge. So here this will recommend us to find which precipitation product is have a best rank. So we selected the 4 precipitation product from here, and you will get the precipitation data from here, and you simulate you use the GRG4 model to simulate the discharge using this all global precipitation product. But before simulating the discharge, we need to calibrate this hydrological model, so which required as a 2 inputs, a daily aerial precipitation, as well another is the potential evapotranspiration. From potential evapotranspiration, I downloaded from ERA website, and I extracted and I keep it as an input to the GRG4 model. And observed discharge was used to calibrate and validate the model. Calibration and validation of model was done on the 3 performance indicator, that was the NSE and KG and percentage bias. And after that, ability to simulate the discharge as well as ability to capture the events and magnitude of the rainfall events, we recommended some precipitation product for the hydrometeorological application in Narani River basin. So as you can see, there is a 6 performance indicator. These are the 3 performance indicator, which is known as a categorical variable performance indicator, because all 3 indicators are used to define the events, capability to check the events detection capability. So we can see and these 3 indicators are used to used to evaluate the global precipitation product based on ability to capture the magnitude of rainfall events. So now you can see we have taken the threshold as a 1 mm per day, because to avoid the human error and another error. This is the threshold value means if rainfall is less than 1 mm per day, we consider there is no rainfall events, and if rainfall events is more than 1 mm per day, we consider the events. So this threshold just differentiate between events and non-events. So based on this threshold value, we make this table, and then we calculate this all equations, all performance indicators for evaluating the precipitation data set. Now these are the just overview of the GRG4 model, which require two inputs: rainfall as potential evapotranspiration, and it have 4 parameters, and then it simulate the discharge. So these are the 4 parameters which was used in this GRG4 model. So now let's move to the result and discussion section. So firstly, we have compared the all precipitation product visually based on the based on the spatial distribution of mean annual accumulated precipitation. So we have compared the all data set with the gauge based observed rainfall data. So we can see most of the global precipitation product have overestimated the rainfall in the lower part and underestimated the rainfall in the upper part of the basin. So now we need to see which precipitation product have a better capability to capture the spatial variability. So we have determined the correlation plot. So we can see these are the observed and all precipitation product, and here this side also observed and precipitation product. We can see the observed and 𝐶𝐲𝐝 have a higher correlation coefficient. That means 𝐶𝐲𝐝 have a better capability to capture the spatial pattern. We can also see in this photo, this figure, this middle part have a higher rainfall in observed, as well as you can see in the 𝐶𝐲𝐝 also able to capture the high rainfall in this region. So but the lowest correlation was found in case of the CPC RT, because these are the real-time precipitation product from the CPC. Now we have also checked the capability to capture the pattern of the temporal variability of the rainfall across the Narani River basin. So we can see the 𝐶𝐲𝐝 and IMERS final have captured the rainfall events, capture the magnitude of rainfall throughout the year, but Persian as well as Persian CC has underestimated the rainfall in this monsoon season. And there is an interesting result. All of the precipitation product have underestimated, while ERA5 have overestimated the rainfall throughout the year. And also you can see there is a similarity. MERA land and MERA 2 have almost the similar performance. You can say it's a similar type of data, but MERA land is only for the land surfaces, and MERA 2 is for globally data set. And also you can see in the ERA5 and ERA late, IMERS early and IMERS late, it have a similar performance. So for the next step of evaluation, we have excluded the IMERS early, and also we have excluded the MERA land because it have a similar performance. So we have selected only 9 precipitation product for next step of evaluation. So now let's see on the effect of topography on the performance of GPP. So now here you can see these are the effect of the topography on the POD and effect of the topography on the false alarm ratio. So in both cases we can see elevation affect the performance of global precipitation product, and at lower elevation you can see the higher value of the POD in all of the GPP. And also in case of the false alarm ratio, you can see if elevation is increasing, that means the possibility to increase the false alarm ratio is also increasing. So we can see like at lower elevation, all precipitation product have performed very well, and they are able to capture the events at the lower elevation region. But in higher elevation region, the all precipitation product fail to detect the rainfall events. And we can see on the now you can see the effect of topography on the performance of the continuous variable performance indicator. So we have taken the two correlation coefficient and percentage bias. In same also in the continuous variable indicators, the elevation affect that is significantly. The all of precipitation, performance of all precipitation product have a better performance at the lower elevation and lower performance in the upper higher elevation zone. Now we have also the calculated all performance indicators based on this across the 6 sub-basin of the Narayani River Basin. So we can see firstly POD, ERA5 have a better capability to detect the rainfall events based on the POD, but there is an interesting result. POD ERA5 have lowest performance in terms of the false alarm ratio because it have a high possibility to detect the rainfall event falsely, and the lowest false alarm ratio was found in case of the CMOF. But there is an interesting result we can see in the IMERS final. It have a good capability to capture the events approximately more than the 75%, and it have also low capability. It have also the low FAR value. You can see lower almost all of the basin. It have a lowest almost lower the FAR value, and in terms of accuracy, there is not much different was found from one product to another product. And so similarly, you can see in the percentage bias. So overall, this some of the precipitation, you can say that some of the precipitation product have a good good at different, like some of the precipitation product have a better capability to capture the events, but fail to detect the rainfall events, fail to detect the magnitude of the rainfall events. So it's very confusing to select the which precipitation product is good for our researcher as well as the decision maker. That's why we have used the compromise programming skill to rank the all precipitation product. So we have ranked the all precipitation product for each of the sub basin. So we have calculated the LP. LP is a parameter which was calculated from the compromise programming, which means it's measure the Euclidean distance from the performance indicator from its ideal value of the performance indicator. So if the Euclidean distance is minimal, we can provide the highest rank. So IMERS final received the highest rank in all of the sub basin except the 𝐾𝐲𝐽-Gandaki. In 𝐾𝐲𝐽-Gandaki, ERA5 received the first rank. So now here it's very clear for our researcher as well as decision maker who can directly recommend the for the Narayani River Basin, IMERS final is the best product for using as an alternative to the rainfall data, observed rainfall data. So now we can also see, now we have selected the 4 precipitation product for the next step of evaluation. So we have selected our selection criteria was like which precipitation product have at least received the first and second rank, and we have chosen the 4 precipitation product. First is IMERS late because it's received the second rank in 2 of the basin, and also we can see in the MERA2. MERA2 also received the 2 second rank in the 2 of the sub basin. So we have selected the 4 precipitation product, IMERS late and IMERS final, MERA2 and ERA5 for the evaluation against stream flow data. So before using the simulation, before simulating the rainfall, simulating the discharge, we have to calibrate, validate the model. So we have calibrated and validated at 2 locations. Narayana Ghat is the main outlet of the river basin. So we can see during the calibration period, the simulated and observed discharge is almost completely matched. It can capture the event peaks as well as the base flow of the river basin, and during the validation also is the same in the both location, you can say. So we can say it's a very good calibrated model. We can also see the NSC value at Narayana Ghat during the calibration. It is about 0.8. It's very high, you can say. And also in the Asing, there is another point which have a NSE value is 0.85. So we have also seen some of the research based on using the GRG4 model. They also got the similar NSE value for their own result. So we have as I discussed earlier, we had 4 parameters. So this X1 is related to the evapotranspiration and percolation, which ranges from 100 to 1200. So our calibrated parameter for X is about 872 for the different location. So you can see from this table. Now, once you have developed our hydrological model, we chosen as I discussed, we chosen the 4 precipitation product: 𝐼𝐸RG late, 𝐼𝐸RG early, and MERA5 and MERA5, MERA2 and ERA5. And we have simulated the stream flow using this all precipitation product. So we can see 𝐼𝐸RG late and MERA2 and ERA5 failed to capture the pattern of the observed stream flow, but 𝐼𝐸RG final is able to capture the pattern of the observed stream flow on the monthly time scale, as well also on the daily time scale. But there is one in 2017 the model failed to simulate. Model have over simulated the stream flow. So still you can see the best performance, the 𝐼𝐸RG final have a best capability to simulate the stream flow using the GRG4 model. And also the similar result we got at the another discharge simulating point, that is the 𝐸𝐶. So same different location at the 𝐸𝐶, we also got the same performance of the GPP. So again we got the 𝐼𝐸RG final as outperform precipitation product among all of the global precipitation product. So over this overall we can say the 𝐶EOPS is the best performed GPP for the capturing the spatial and temporal pattern of the rainfall events on monthly and daily time yearly time scale. And we can also conclude that the topography greatly affect the performance of the GPP, and the better performance was found in the lower elevation zone. And then also the another interesting result, we can support our previous researcher that the performance of GPP varies from basin to basin, as well as also depends on the evaluation criteria. And now the fourth conclusion is about the like the 𝐼𝐸RG, as we discussed, 𝐼𝐸RG final was getting the best performance in terms of each step of the evaluation criteria. So 𝐼𝐸RG final received the first rank in the five sub-basin, and second rank in the 1 remaining sub-basin. And also we can say these are the based on the evaluation against the gauge data, and second was evaluation against the stream flow. So we can say 𝐼𝐸RG final have both capability. It's able to capture the rainfall events as well as able to simulate the discharge in the Narani River Basin. So this research I strongly recommend to use as 𝐼𝐸RG final as alternative of the rainfall data in Narani River Basin for our decision maker and researcher. So this all about my presentation. Thank you very much.
Okay, so yes, thank you, Sonu, again for, I would say, very rich information, and I see that you've tried to cover that in such a short time. So thank you very much. So with that, I would like to open the floor for questions and comments from the audience. Please, those who can want to ask questions to Mr. Sonu, please introduce yourself. Yes, Saurabh, I see you raise your hand.
Thank you, Dr. Locke. Yeah, Sonu,
Yes.
thank you. I'm Saurabh, PhD student at WEM. Very nice presentation and very comprehensive work. So I have a small confusion from the study. One is, I just divide that into 2 questions. One
Yes,
is you compared that with some observed data of Narani River Basin.
Yes,
So was your data, observed data, complete set of data, or was there any missing data? So if there was any missing data, how did you fill up that missing data, because you are comparing again with the global data sets.
Yes.
And second thing, once after comparison, if two of us are doing a drought assessment and a flooding assessment, so directly can we select the final result that you said, image or 𝐼𝐸𝐻, yeah? So is this for all type of assessment work or some specific type of assessment work? So any type of study, impact studies can be done from this selection or for the specific work?
Okay, sir. So I would like to thank you very much for your questions. That's really interesting questions. This type of questions arise by many of the researchers. So firstly, I would like to answer the questions related to the filling of the data. So I didn't fill the rainfall data because I didn't wanted to introduce the additional error in this evaluation. So what I have done, if I detected some missing data in the rainfall data set, so I have also considered that there is a missing data in the global precipitation data set. So we exclude that period. If I suppose, for example, I have a missing data from 2003 to 2004, so I have excluded that period for evaluation. So I have not filled any data by any techniques for the evaluation criteria. But yes, I have filled the data for when I was doing the evaluation against the stream flow data. So I have filled the all missing data using so for that technique, I have used the average method. Like I have taken the average of whole station at the same days and fill the data. I fill the missing data on that day. And next, your questions was based on recommendation. Yes, my study have take care of whole type of studies. You can my recommend, like you are using the flood modeling, you can directly use the 𝐼𝐸𝐻 final for any river basin. There is no doubt. But if you are working on the flood forecasting, you cannot use, because this data is not available on real time. So for real time application, you can still I will show I can show this ranking technique. So for the non-real time application, you can use the 𝐼𝐸𝐻 final for any type of application, because it was ranked based on ability to capture the events as well as the ability to capture the magnitude of the events. So we have used the 6 indicators which can take care of all type of studies. So for the non-real time, finally I will say that for non-real time you can use 𝐼𝐸𝐻 final for any type of studies, but for real time application you can use 𝐼𝐸𝐻 late. But in terms of ability to simulate the discharge, you can see that it have not good capability to capture the stream flow. But still, the performance of 𝐼𝐸𝐻 late is improving. In the last, you can see from the last period of simulation, it have a very good capability on the capability to capture the stream flow on the monthly time scale. But on daily time scale, I think we cannot use 𝐼𝐸𝐻 late for the stream flow, stream, like for flood application like that. So we need to bias correct this data set before using for the flood application. Yeah, for flood modeling, we can use 𝐼𝐸𝐻 final, but real time flood forecasting and crop forecasting, you have to bias correct this data.
Okay, thank you so much. Thank you for the answer. Thank you, Dr. Law.
Yes. So Saurabh, is the response okay for you, or I still see your hand raised?
Oh, sorry. I'll
okay.
take out my hand.
Okay, yeah, thank you. So I think we have another hand raised from Biru. So Biru, please go ahead.
So no, that was a nice presentation. Thank you. I have also conducted some few research in satellite rainfall products over Thailand. You might know the northern part of Thailand, the upper Nile River Basin, and also in Sri Lanka.
Yes.
So actually, what I'm sharing my experiences, �emerge actually did well, TRMM products, right? But the thing is with Persian, for Sri Lanka and Thailand, what I observed was I simulated the HMS model, right, for the both catchments. It actually underestimated, and I see that for the Nepal and Narayani River Basin, which has a tropical climate, then it also underestimates, right, the Persian CCS, Persian CBR. So I think my recommendation was also that there should be some improvements for the retrieval algorithms to measure rainfall. So I think you're also getting same kind of. Can we have a discussion? Like, what do you think? Like, might be the reason?
So basically, you would like me to share my idea on this, why these precipitation product are underestimating, like Persian are underestimating the rainfall, right?
Yes, yes, that's the thing.
Yeah. So as I have review the precipitation product, because the Persian CCS and Persian product, these both of product are not calibrated with the weather parameters, and they have directly mentioned there on their website. These are the direct precipitation product coming from the satellite as well as the model. But what happened, like in terms of the Persian CDR, this is the calibrated model using the observed rainfall data set.
Yes.
So that's why you can find the better ability to capture the rainfall events, capture the temporal pattern of the rainfall in case of the Persian CDR. But in Persian CCS, because this precipitation product is for the real-time application, as I will also recommend you, like the Persian have developed the new precipitation product for the
PDR, no?
Yeah, for the real-time application. So still we need to evaluate that precipitation product for the
I checked it,
real-time
but
application.
still not doing. I checked PDI, I mean, Naval time scale.
Yeah, now it's not available. Maybe it will available soon. I was also checking that data set.
Yeah.
Thank you very much.
And then same thing in high elevations, this didn't detect properly, but Emerge 6 version, I used the version 6, but it was okay, no? So I think
TRM, it was okay.
It was okay.
Yeah, because TRM, like IMERGE final is also the advanced version of, like, upgraded version of TRMM product.
Okay, thank you, Sonu. Thank you very much. Right, it was a very nice presentation.
Yes, thank you, Miru, for your question, and also Sonu again for your very insightful presentations. And again, I would like to say thank you again for Grace and for one of the attendants, especially the alumni who have spent your precious time to join with us today, and as well the prospective students, Ansita, Ms. Q, and also who have joined us today. So lastly, I would like to say please take care, as the COVID is still there, and we're looking forward to welcoming you again in 2 weeks. So before I close the section, I would like to make the final announcement related to the next presenter. So please allow me to share my screen. Yes, so our next WEM seminar series will be in August 18, 2021, and the presenters would be Ms. A. Kandamor, and the second presenter would be Mr. Chalamchon Latun. So please coordinate with 𝐂𝐲𝐝 for your flyers for us to make the announcement on our website. So once again, thank you everyone. Please stay safe, and then we'll be seeing each other again in 2 weeks' time. Thank you. Goodbye. Have a nice day.
Thank you.
Nice day.